Okay. So just a quick recap for the recording. We don't meet next week during break. Homework 4 is due before break. Homework 5 we'll work on after break. And then after homework 5, we'll do test 2, which will be on Canvas. All right, we are doing notes. Okay, we defined a random variable, and we talked about the mean of a random variable, and its symbol is mu sub x. Sometimes just mu, but I'm going to put subscript x. Okay. This is equal to the sum of all x times p of x. Let's see if we can get the, sorry guys. All right. And I have a couple of examples. Let x be a random variable. I cannot get this set up the way I like. Okay. That's good enough. X. Okay, with the following probability distribution. And by the way, a probability distribution can be a table or a graph or a formula that lists values of your variable and the probabilities for each value. And we have a table. So our table lists x next to p of x. So this side values of x and this side are probabilities for those values. Okay, we have 2, 3, 4, 5. On the other side, it's 0.57, 0.23. This just looks so tilted to me. That's a bit better. Okay, 0.06, 0.14. And you should always have this probability column add up to 1. So I checked, the total is 1, but that needs to be the case. Okay. The mean for x.
I was just wondering, Professor, is it just personal opinion or is it like special that you make the X's like looking Roman numeral looking? If that makes
It's really kind of a style, but also it's because sometimes it helps make it look more capital and like little x. Sometimes, let me see. So you could just put a capital X like this, but sometimes if we have like unknown is the capital X, and if you have a like specific, it would be like little x. Like in statistics, capital X is when you have no like set value. It can be any of these numbers here, but when you pick one of those numbers, we're still recording. So anyway, it's not that important, especially since you'll be taking an online test. So when you type your mean, it'll probably look like this. But and if you put a lowercase x, I'm not going to mark it down or anything like that. So it's just to help to know that it's capital X because statisticians can be a little picky about it, but I'm not that picky. And also, you could leave this part off if you want to. Anyway, yeah, this is a style that one of my teachers used, and it helps me know that those are capitals, and I think that's all we need to say about that. Thank you. Okay, so we take 2 times its probability, add 3 times its probability, and then keep going. 4 times this plus 5 times that. I like this little guy here. Okay. 2 times probability to add. Actually, I'm jumping into it already. I'm going to back up a little bit. The formula would be sum x x. So put in 2 for x. Add 3 times probability for 3. Add 4 and then put in 5. Okay, 2 times 0.57. Okay, 3 multiplied by, let's go, 0.23. 4 times 0.06. 5 multiplied with the last probability. All right, and then I put it through a calculator and I got 2.77. And of course, like double check it if you have time. Okay, so a new probability distribution. This semester, we're going to stick with x. So our random variable will be x. Let x be a random variable. We're going to have this table for this new variable x and all of its probabilities. This time, we're going to do x equal to 6, 8, 10. Probabilities are 0.49, 0.24, 0.27. And I mentioned before, this side should have a total of 1 every time. So I checked it, but you can always double check it. That 0.49 plus 0.24 plus 0.27 equals 1. But that's just a little fun.
I got one.
Hmm?
I confirmed it with my
Oh, you checked it. Thank you. Okay, but we're just using this part here. Just focus on this and find the mean. So put in 6, put in 10, put in 6, put in 8, put in 10. 2. Okay, mean for x is the sum of x times p of x. This time x is 6 and 8 and 10. So 6 is x plus 8 over 8. Last one, we'll put in plus 10. Probability for 10. Okay, put those numbers in. Probability for 6 was 0.49. Okay, 8 times 0.24. No, not then 10 times 0.27. Actually, if we're going to do it all long ways on the whiteboard. Okay, this plus this equals, I got 7.56. Alrighty, let's see. Double checking.
Confirm.
Cool. Got one more of these where x is a random variable. It's a new example. Let x be a random variable with the following probability distribution.
Is it possible, Professor, to either this one or one exam where we get this different that said could be?
It broke up a little at the end. If you could repeat that last part. Like x could be.
Yeah, so in classes, different ways would be presented the distribution, and like whether that's the table or a graph, or I forgot what one was, but could we do maybe a couple examples at least today or in the future, maybe looking at the distribution in different ways, but solving these same.
Writing the mean. Let me think about that.
Of course, within reason, because it'd be hard to do a graph on a whiteboard. But no,
Yeah. Well, let's see. We'll talk about that for just a sec before we do this next one, before we go through this. Okay. So I mentioned probability distribution. Is a table, which for us is going to be the focus, but it could be, like you mentioned, a graph, or it could be a formula. Hopefully this will be fixed today. Thank you everyone for sticking through these meetings. It cuts out. But for everyone who's still here, I was trying to tell a little bit about probability distributions. We're going to use tables. And I want to address that question about finding the mean for formulas. A little iffy about doing it for a graph. Anyway, so its probability distribution can be this, this, or this. That lists values of the variable. Okay, we'll get back to this. And probabilities. Okay. So I'm thinking I might grab a book in just a sec, but I know, as we had the table, it was to find x times p of x for that discrete random variable. Just go through stuff like we've been doing examples for. Okay, so like a discrete random variable where you can list the outcomes in a table, we can find that mean the way we were doing before. There are there are other random variables that if you know what its distribution is, there's a formula to find the mean. Like the one we're going to focus on is a normally distributed random variable. There's a formula for the mean, and there's a formula for the standard deviation. I'm going to have to check what that formula is, but it's going to be mu sub x equals. All right, let me see. And while I grab the book, there's a couple others. There's a binomial distribution, a Poisson distribution, there's a geometric distribution. All of those variables also have a formula and a formula for the distribution and a formula for the mean. So let me see if I can grab some stuff. We're not going to go there though. Heavy books. There we go. Thanks for being patient. Okay, so we're just talking about some of this stuff for fun. I find it kind of interesting since I've been doing stats recently. All right. All right, something, the normal distribution, the mean. A little bit more. If I can get a book instead. Okay, let's try going here first. So what we've been using is called the arithmetic mean. And let's see, values, something, something. Okay. All right, so I wanted to talk about like a specific random variable like the normal RV. Let's go. Okay, I'm getting off track. Anyway, let's do. Just going to kind of do a general explanation and not get too specific on any certain variable, even though we are going to get into properties of the normal variable. I'm just going to say that for a random variable that can be described by a formula, written as a formula. I'm going to list a couple examples, like there's one called geometric. There's one that's named after, I think it's a French statistician. It's Poisson, P-O-I. Poisson. We're going to talk about the normal distribution. There's one called, there's a uniform distribution. For certain distributions, there's a formula that's a different formula, like an easier, just put a number into it kind of formula to find the mean. It's not the same formula every time. Like when I took stats, luckily my teacher let me use a whole tape, like a cheat sheet, so I didn't have to memorize them. But for each distribution, there's a way to find the mean. And for the next distribution, you can plug in numbers to get the mean. All right, but when we use, which is coming next, after this example, we're going to talk about the normal distribution, and I'm just going to tell you what the mean is. Okay, and then before I leave this, let me think about finding the mean of a graph. I think all I want to say about that is the mean is a measure of center. So if you have a graph, it's a value that marks where the balance point is on the graph, where like half of the data is on one side and half of the observations on the other side. Okay, so back to the example. X is a random variable with the following probability distribution. for x. This time we have negative numbers. We're going to start with -4, then -3, -2, -1. Probabilities are 0.12, 0.27, another 0.27, and 0.34. And this total should equal 1. And we're just going to find the mean, which is the sum of x times p of x for this table. Sum x dx. Put in -4, and then -3, and -2, and -1. Here, it's -2. -1 multiplied with this probability. And alrighty, putting in the probabilities. So we have -4 times 0.12. -3 multiplied by 0.27. -2 times 0.27. -1 multiplied with 0.34. I'll put a little bit of what I worked it out as. First term is -0.48. And subtract 0.81. Subtract 0.54. Last one, minus a 0.34. And I get a negative number, -2.17. Okay. One more thing I want to say before we get into the normal distribution. This little note aside. The mean of a random variable is also called the expected value of the random variable. Okay, I'm not going to put it in the homework or on an exam. I just wanted to bring it up, and I will show you the notation. It's just common in a stats class to write like expected value of x. It's capital E of x. So expected value of x would equal the mean of x. They're the same thing. And you can find it by taking the sum of x times p of x. So I just want to recopy, it looks messy. Expected value of x means the same thing as the mean of x. And this is the sum of x divided by p of x. Okay. So let's see. So I've been sort of jumping around in chapter 17. I'm not exactly sure which section the normal distribution starts in, but this will be kind of the last thing we focus on. So we want to talk about a normally distributed random variable, finding probabilities under the distribution, and then maybe after break, I'm thinking about going over the empirical rule, but we'll see if we want, we'll see if we get there. A random variable is normally distributed if I can try this again. If it's either histogram or relative frequency histogram, either one, if it has the shape of a normal curve or if it's bell-shaped. Random variable is normally distributed if its frequency distribution has the shape of a normal curve, which we'll talk about, or we'll put if its frequency histogram distribution has the shape of a normal curve. We'll talk about properties of the normal curve in a second, but overall it's like a bell shape. So there's one peak, and it's over a horizontal axis, where these are the variable, like values of your variable x. Okay. Down from the top and approach the axis, but don't cross. Get very, very close, but never go past. And then it's symmetric, so the same thing on the other side should match. Cool. Okay. And then that center is right over the mean. And then where it curves down and then switches to kind of curving over and up, like down and then switch back up again, that's called an inflection point, right about there. And here too, it comes down and it kind of comes back up right here. Inflection. Okay. I think that's good enough drawing, so we can list properties of the normal curve. The first one is that it's symmetric about the mean. The second one, inflection points are at mu minus the mean and mu minus 1 standard deviation and mu plus 1 standard deviation. So here you add 1 standard deviation, and here if you subtract 1 standard deviation, it's this point there. Okay, so let's go here, this place, which is mu plus sigma, the mean plus 1 standard deviation. And the mean minus 1 standard deviation. Right there. Okay, and the area under the curve is 1. So if the area under this curve is 1, then this side is 50%, and on the other side you've got 50% when you cut it in half. So half the area to the left of the mean, half of the area is on the right side of the mean. Anything else? Last one. Number 4, the curve approaches but never crosses the horizontal axis. That's where we're going to end our list of properties. And I think we have time for like one example, and then we'll come back next time and do more with working to find areas under the normal curve. Okay, let's try this. Let x be a normally distributed random variable. With mean mu sub x equal to 65 and a standard deviation which was sigma and equals 10. Draw the graph of x. the distribution of x. I'm just gonna put x. Okay, it's normally distributed, which means it's going to be bell-shaped. It's centered at 65. So we're going to have a peak right there. This horizontal line, that's a number line for x. This is the distribution for x. This is giving us all of the probabilities for the variable. So that is the probability distribution centered at the mean, 65, and the inflection points out here. Are within one standard deviation. So if you go this way, take away 10 to get to 55. Here, add one standard deviation. So add 10, 75. And that's the most we're going to have going on for these graphs. The curve, it doesn't cross the axis, it's centered at the mean, and we're going to have inflection points at the mean minus one standard deviation and the mean plus one standard deviation. That's good enough. Where are we? We have a couple minutes left. Let's try one more. It's kind of easy. And that's it. Let x have the following distribution. Okay, so we've got a number line for x. The probabilities for x are going to be bell-shaped, and it's centered at 26. Okay, we're going to pretty much just wrap it up. So all we're going to ask is, what is the mean? So looking at this graph, the mean would be 26, center. Cool. Okay, so that's it. We're going to do a lot more practice with drawing these and finding areas underneath of these curves when we come back for break. Okay.